Hello, this is Physics 12, Lecture 6. We continue Newton's second law, but today there is friction. Let's do some examples. I have a box on an inclined plane. This inclined plane has a hinge here. Therefore, the inclined plane can be tilted furthermore or less. It can be tilted this way. Okay. If the angle is small, like this, so the box will stay there without motion because there is friction between the box and the inclined plane. If I raise the inclined plane, tilt it more, then I have this situation. Now, if I tilt it more, this will slide down, right? Can you imagine that? If I tilt more, this will slide down. The reason it slides down is because the friction force is not large enough to prevent the box from sliding down. Now this question is to find the angle so that the box is just about to slide down, or the box starts to slide down. What is the angle here? So let's give some information. The coefficient of friction is given 0.3. The mass of the box is just m. I want to find the theta, the angle theta. If I increase the theta, at the instant the box starts to slide down, what is the theta? And this angle is what we want to find. And let me erase this part. I need a free body diagram. Okay. mg is the mass, is the force of gravity. Force of gravity is mass times g. So this is force of gravity. I can resolve the force of gravity into two components. One parallel to the inclined plane, another one perpendicular to the inclined plane. So this is the component parallel to the inclined plane, and this is the component perpendicular to the inclined plane, right? This is perpendicular to the inclined plane, 90 degrees, and this is parallel to the inclined plane. Okay. This angle is theta. First of all, I will make a statement. This angle is also theta. Now remember, some time ago, I mentioned that if you have two angles and the two sides of one angle is perpendicular to the two sides of the other angle, then these two angles are equal. Look at this angle and this angle. You see this side is perpendicular to this side. This side is perpendicular to this side. Therefore, this angle and this angle are the same. Do I block the view? Block your view? Let me come here and say it again. The two sides of this angle, this side is perpendicular to this side. This side is perpendicular to this side. So, this angle is equal to this angle. This relation is very important. We will use it very often when we have a geometry. Okay. Then what is the this component? This component will be mg. This side is the opposite side of angle theta, so it's mg sine theta. And this is, refer to this angle theta, this is the adjacent side, so this is mg cosine theta. Now, other than the force of gravity, we have other forces. One force is the normal force. So this is the normal force. Remember that normal means perpendicular to the inclined plane. This force is perpendicular to the inclined plane. That's why we call it normal. Normal is perpendicular. There is another force. Because today we are talking about Newton's second law, with friction. Another force is the friction force. Our question is, when the theta is large enough, this block will slide down. Because this block will slide down, the friction force is opposite motion. The friction force is this way. So I have friction force this way. So this is F friction. Remember, friction force must be between two surfaces. What are the two surfaces? The bottom surface of the block and the surface of the inclined plane. So friction force exists between the two contact surfaces. All right. Now, when the box is just to start sliding down, just start sliding. At that moment, all the forces must cancel each other, and the resultant force has to be zero. This applies only when it just to start, all right? And this is what we want to find. What is the angle when the box just start sliding down? So, this force, mg sine theta, must equal to the friction force. And the normal force must equal to this component, mg cosine theta. So, this is the condition. F friction is equal to mg sine theta. And mg cosine theta is equal to the normal force. There is also a relation between the friction force and the normal force. That relation, you have to memorize it. It is mu times normal force. Friction is coefficient of friction times the normal force. Okay. Now we can write the detail. Okay. This is mu F normal. So I can write this. This is mu times Fn. But Fn is this. So this is, let's continue my equal sign. Mu Fn is mg cosine theta. Therefore, what I have mg sine theta equals mu mg cosine theta. Okay. I need more space. Let me erase this part. So mg sine theta is equal to mu mg cosine theta. So this is our relationship. But then you see mg, and this mg can be cancelled. Therefore, sine theta equals mu cosine theta. Let me divide both sides by cosine theta. Then I have sine divided by cosine is equal to mu. Sine divided by cosine is tangent. So I have the relationship. This is equal to the coefficient of friction, which is given 0.3. From this, you can find theta. Then the next step is to use a calculator. So using the calculator, you get the answer 17 degrees. This is our final answer. You get the answer, the angle 17 degrees. If the angle is more than 17 degrees, then it will slide down definitely. When it is exactly 17 degrees, it will stay there, but if you have 17.001 degrees, it will slide down. All right? So that is how we do this problem. Remember that if you have any question, you can text message me, okay? Do you have my telephone number? In some of the previous videos, I put on my telephone number. You can text message me asking questions. All right, this is the first example. Let's have the next example. I have a box. The box is resting on an inclined plane. And the box is tied to another box. So here is a pulley. Okay, the pulley is fixed to the inclined plane. All right. This angle is 35 degrees, and M, the mass is not given, but this mass is given, 5 kg. And the coefficient of friction is 0.25. This is the situation. So what does the question want to find? The question wants to find this. Now listen. First, let's discuss the situation. If m is very small, it's not heavy, it's very light. If that is the case, then this will go down and this will go up because m is so small. So now you increase the m. Probably it will still go up because it's not heavy enough. Increase the m continuously, you will imagine that if it's so large, then instead of going up, this will go down because this is so heavy, right? Then there is a situation when the m is big enough, it almost wants to slide down, but not quite. It will stay there, not moving. But if you increase the mass by just a little amount, it will slide down. So that is the situation. Under that situation, what is the mass? What is m? That's what we want to find. Remember, this m is the largest mass such that everything is still at rest. But when that mass increases even a little bit, then this mass will slide down. Okay, where is the friction? Of course, the coefficient of friction is given. So the friction is between this bottom face and the inclined plane face. But in which way is the friction force? It's between this and that, no problem. But the friction may be this way, maybe that way, right? In which way? Now you have to know, have to remember the problem. The problem says, if m just increase a little bit, this will slide down. So it has a tendency to slide down. That means the friction force is opposite. The friction force is that way. You got it? Let me repeat again. Because our problem is to find the mass such that it almost slides down. Therefore, the friction is against it, upward. So, let's have the free body diagram. Just like the last problem, we have the force of gravity, mg. And we resolve mg into two components, one parallel to the inclined plane, the other one perpendicular to the inclined plane. So let's draw a rectangle. So this is a component parallel to the inclined plane. Remember in the last example, the parallel component is sine theta. The theta now is 35. So this is mg sine 35. And similar to the last problem, the component perpendicular to the inclined plane is the cosine component. Which angle is 35? This. The reason is exactly the same as before, because the two sides of this angle is perpendicular to the two sides of this angle. Okay? I'm not going to the detail. Now, there is a friction force. Let me put down the arrows. Okay? This is a component direction. This is a component direction. And as before, there is normal force. Okay. Normal force. And there is a friction force. There is also one force. The 5 kg has the force of gravity 5 times g, or 5 times 9.8. This is a force of gravity. Because in this question, nothing is moving so far. Nothing is moving at this point. Okay. So this down force is 5 times 9.8. This up force must be 5 times 9.8. Because this is not moving. So the tension here is 5 times 9.8. The tension here, the tension here, they are the same tension. So 5. So this force is 5 times 9.8. So this force will show up in the free body diagram here. 5 times 9.8. Okay. Now, it's quite similar to what we had before. So the force of friction is coefficient of friction times the normal force. The friction force is coefficient of friction times normal force. But the normal force and this force are opposite and equal. Therefore, the normal force is mg cosine theta. All right. So now let's write the sum or the resultant of the forces along the inclined plane. Along the inclined plane, the resultant force should be 0, is it? Or we can say in another way, this force plus this force should equal to this force. So these two forces are this way, and this force is this way. So this plus that should cancel this. So I can write mg sine 35 is equal to 5 times 9.8 plus mu mg cosine theta, cosine 35. All right. Then, what I want to find is m. So I like to move this to this side. Okay. M 9.8 sine 35 minus mu is 0.25 m 9.8 cosine 35 this minus that is equal to 5 times g. 5 times 9.8. Okay, look at this relationship. I have the unknown, which is m. And that is exactly what I want to find. I want to find what m is. So this equation will give us m. So the next step, you can factor out the m. Oh, one more thing. 9.8, 9.8, 9.8. Cancel. So m, factor out m, sine 35 minus 0.025 cosine 35 is equal to 5. You have it? You follow? Therefore, m is just 5 divided by this bracket. So now you use a calculator. What is it? It is okay. So you use a calculator to do this part, and it's 13.56 Newton. No, not Newton, kilogram. And to round it up, it's roughly 14 kilogram. So the mass is 14 kilogram. And that is the answer of this problem. Any questions? Maybe I can write my number down. Text message me if you have any question. Okay? Let's see how much time we already spent. So maybe we can do one more. Let's see now. What else can we do? Okay, let's do one more question. All right. Again, I have an inclined plane. The angle is just 6 degrees. It's not big, just 6 degrees. So I have a mass on top of the inclined plane. And the mass is not given. You can say it is m. All right. Yes. And the mu, coefficient of friction, is 0.14. Okay. Now, the question is this. You give this mass a push. Give the mass a push. You push it, so it slides down, right? So it slides down with the initial velocity 12 meters per second. So this is the initial velocity, 12 meters per second. So it moves because you push it. But there is also a friction. The friction is against the motion. So you push it, it slides down, the friction is up. So the friction force is up. F of friction. Friction force is up. There is also force of gravity mg. There is, as before, there is a component along the inclined plane, and there is component perpendicular to the inclined plane. So the component along the inclined plane is this, and perpendicular is this. So this is this one is mg sine 6 degrees. Always remember the component along the inclined plane is the sine component, sine 6 degrees. Okay. And then the vertical, and then the perpendicular component is cosine component. So this is mg cosine. And again, there is normal force. So normal force normal is equal to this, mg cosine. And the friction force is normal force times 0.14. So the friction force is the normal force times 0.14. So this is a friction force. If you use a calculator to find the magnitude of this and to find the magnitude of this, you do not need exactly what m is. Just compare these and you will see that this is larger than this. You will find friction is larger than mg sine 60 degrees. You will find this. What does that mean? That means since this is larger than this will slow down, you see? The mass will slow down. So it slows down, slows down, slows down, until somewhere it stops. It stops. So let's see this dotted position. This dotted position, it stops. And the question wants us to find what's the distance between this point and this point. So what is the distance? To find the distance, because it slows down, to find distance, we need this formula. V2 square is equal to V1 square plus 2 acceleration distance. So V2 is this. This is V2 here. V2 is 0 because it stops. So I have 0 here. V1 is 12 plus 2a d. D, I don't know. D is what I want to find. To find D, I must have A. So what is A? A is Newton's second law. Force net is equal to ma. This net is in along the incline. Why this net force is along the incline? Because it slides down, the acceleration is along the incline. If the acceleration is along the incline, my net force must be along the incline. And what is the net force along the incline? It is just this force, because this is bigger. This minus that. That's the net force. Because the net force is this way. But it slides down. The acceleration is this way. Therefore, the net force is negative. Okay. But don't worry about the negative or positive. Let's work on the magnitude. So, what is A? A is the net force. Net force is FF. The friction force minus mg sine 6. Divided by mass. What is friction force? Is this. mg sine 6 mg cosine 6. Friction force, it's this, sorry. Friction force is 0.14. mg cosine 6. That's the friction force minus mg sine 6. And this total thing divided by m. Now you see, I have the m on top. Yes, I have m here and m here, and I have m here. Therefore, m cancels. I know g. G is 9.8. Cosine 6 and sine 6, you can find it from the calculator. So this can be found. Okay, this can be found. No problem. Once you have the A, put the A here. Using this equation, you can find D. Do you follow? Let me repeat. So A is the net force divided by mass. The net force is this, mass, and the mass cancels, so you can find the acceleration. Once you have the acceleration, put the acceleration here, you find the D, and the D is what we want for this question. So D is, I'm not going to use a calculator to write down all the numbers, I'm not going to. So the D is 211 decimal something. So D, my D is 211 and the decimal something. Yeah. The calculator will give you many digits. So this is meter then. This meter. All right. So roughly you can say 210 meters. All right. So as I said, I give you the telephone number if you have any questions or you do not follow my work here. Maybe I did it too fast or whatever. Whenever you do not follow, give me a text message. And I will answer your message as soon as possible. Good. That is today's lesson. Bye-bye. See you next time.